Hello, everyone. So we have done the first part of the Sine Law 5.5, and we are sort of going to backtrack a little bit. In 5.4, it's the math lab, wherein you are supposed to be sort of doing an inquiry towards figuring out how to solve triangles involving the Sine Law. Now, I leave 5.4 for you to do. Um, what I'm going to be doing would just be very similar to what you will have found out from 5.4. All right. So I strongly suggest that you do 5.4, but if you decide to skip it, that is okay. All right. Now, I also was hoping that before you watch this video, you would have watched the other video that I would have provided to you below the message that I posted. It is another way of looking at how to determine how many triangles there are. Now, the problem that we have is this. Whenever we are solving triangles, and to solve a triangle, it means you are going to find all of the missing angles and missing sides. Now, it is very easy to do that, especially when there is a picture. Okay. Now, the problem is if there's no picture and you are just given certain information like one of the angles and then two sides, then how would you solve the triangle? Meaning, how would you find out what the other angles are and what the other sides are? Now, what you cannot do is to assume, all right? There is a way to do it, and that is what we're going to talk about today. This is called the ambiguous case. Now, why is it ambiguous? Because ambiguous in English means it's unclear, open to interpretation, and whatever other ideas you may have about that word. Now, as you can see, I already wrote there in text, when there is no diagram or sketch, it will be up to you to think about how a triangle looks like depending on the information that is given. Now, the ambiguous case arises when you are given the lengths of two sides and one angle. All right, I'll say it again. When you are given the lengths of two sides and one angle, and that angle is opposite one of the given sides. Okay? Meaning to say, that angle would be opposite one of the given sides, and then the other side that is given would be one of the arms of the angle. Now, I want to point that out to make it clear because you might be thinking that, oh, so you have an angle and then the other two sides are the arms of the angle that is given. That is not it, all right? We are talking about a case wherein the angle that is given would have an opposite side, which is also given, and then the other side that is given is the arm of the angle, okay? So if that is sort of unclear right now, um, take it easy. We will get there as we go further into this discussion. Now, if there is an ambiguous case, there are three possible outcomes. It could be that there is no triangle that exists, even if you are given a certain set of measures, okay? There's no solution. It is also possible that there is one triangle that exists, not exists. Okay, so that's just a mistake. All right, maybe I can fix that now. All right, exists. Okay. In which case, there is only one triangle and only one unique solution. Now, there is also the possibility that there would be two distinct triangles, distinct meaning two different triangles that would come out if you're given a certain set of measures, okay? So, as you can see, I have two triangles right now. I don't know if you notice, but this side right here, sorry, this side is 16, which is also the same as this side in the other triangle, all right? And this side is 10, which is also 10 in the other triangle, all right? And look at the angle that they have, okay? They also both have 30 degrees on the bottom. So as you can see, these two triangles have pretty much the same sides and one angle that is also the same. But clearly, those two triangles are different. Just looking at the pictures, they're different, right? So what I'm saying is, in this case, if there was no picture, if the only information given was that there are two sides in a triangle, one is 16, one is 10, and then there's another angle given, which is 30 degrees, how will you know how many triangles there are? All right, sort of this way. So it is the same question that you will have in the previous pictures that I showed you, although this time there is no picture. I'm just coming up with a certain set of information wherein angle A is 30 degrees, little a is equal to 10, little b is equal to 16. How many triangles can you have? Now, if I did not show you those diagrams prior, I don't know if you would be able to figure out that there are two. Now, if there's no sketch or diagrams shown, do not assume. Do not assume there is one triangle. Do not assume there are two triangles. In fact, there are times when there will be no triangle at all. Okay? All right. So let's take a look at this. To help you with problems like this, always set up the diagram this way. All right. So you will have your angle down here. This is your angle, all right, down at the bottom. So whatever angle is given. So in the problem that was shown earlier, the angle was 30 degrees. Okay, we're not concerned with that. I'm just showing you what I would like you to do. Okay, so there is an angle given. There would always be an angle given. So let's call it angle A. All right. Now, hopefully you remember that when you come up with a triangle and you are labeling the different vertices of the triangle, the vertices would be labeled with capital letters, okay? And the sides would be labeled with little letters or lowercase letters that would be opposite the angle, all right? So what does it mean? So for example, if I were to continue with this, if I'm going to um, complete the triangle, so I have this, C, okay? Angle A is down here, angle B is down here, angle C is up here. Where would little a be? It would be opposite, all right? Opposite the angle, this is little a, okay? Where's little b? Right here. Where's little c? Right here. So you need to make sure that you understand that, because if you don't, then we're gonna have a big problem here, okay? It just takes practice, okay? All right, and then what? So when I told you always set this up this way, so let's say you're just given an angle. You're given an angle A, all right? And then you're given two other sides. The other two sides would be this one, this would be side B, and this would be side A, okay? Now, if you notice, I um, did this on purpose wherein side A did not reach up to the bottom here, all right? So I'm just saying that, okay, we have an angle A, and then we have two other given sides, and one given side is opposite the given angle, while the other given side is um, one of the arms of the angle that's given. Okay, so how do you solve a problem like this? Well, your question is, you should begin with thinking about, is there going to be a triangle in the first place? Okay, you don't know that. Okay, now think about it this way. Suppose we are given values, okay, for A and B. The problem is, you don't know whether the measurement or the length of A is enough to create a triangle. All right, what does it mean? What if A is only up to here? Is only up to here, the end of it, okay? Now, in that case, do you think you will be able to create a triangle? Well, I think A is too short if you think about it. Now, even if you were to swing it this way, all right, if you're thinking, okay, maybe there's a way to make a triangle here. If you were to swing A going this way, all right, I think it's still too short, right? So really, in that case, you will never be able to create a triangle. So that is one of the possibilities we're in. Nope. If you are given two sides and then one angle, it is possible that there is no triangle that you can make, right? What about, so this is zero, no solution, no triangle. Now, what's the point in saying no triangle? Well, if there's no triangle, there's really no angle, no side to solve because you can't even create a triangle. Okay. Once we are able to see how many triangles there are, if there is or there are, then we can use the sine law to determine the different sides and the other angles that are missing. Okay. Now, what is another possibility? So again, we have this angle A. All right, this is side B. This is A. All right, oops, this is A. Now suppose that A is enough to get to the bottom. So that means if A is enough, and let's just say that it creates a right angle here. Well, that is a right triangle, isn't it? So as you can see, in this case, there is one triangle that you can create. Okay? Compare that to the previous picture wherein the A is too short to make a triangle. Now in this case, it just so happened that the A, the measurement of side A is enough to get to the bottom, so that's okay. All right. Now what is another possibility? Excuse me, wherein there would be one triangle. Well, what if it was like this? Angle A, this side B, this is side A, all right? And it is enough to hit the bottom, all right? So again, there is one triangle. Okay, now, if you're thinking, all right, so no triangle, there are two possibilities to create one triangle, and then what about if there were two triangles? Well, do you remember the first one that I showed you, wherein it looked like this? This is just a um, quick sketch of it. All right, wherein this one was 30 degrees. This is a I think it was a 16 and 10 if I'm correct. Okay, yeah, this is a 16 and this is a 10. While the other picture was like this, all right, wherein this is a 10, this is 16. This is your 30 degrees. Oops. Okay. In this case, there are two triangles. Yeah. Okay. So I just showed you the different possibilities that you can come up with depending on the information given. Again, I'm asking you to watch that video. There's a girl who is explaining how to look at the different possibilities. Also, there are animations which you might find easier to understand if this does not really make sense to you. Or look online. There's so many resources. This is a lesson that is really hard to understand. Okay, so do not be frustrated. It is not something that I always had success with. All right. Every year, I'm not sure how many kids actually fully get it. It's hard. Okay. Okay. So let's get into how you solve this with numbers. Okay. Let's begin with what if there is no triangle possible? Okay. So let's see if this is the kind of problem you have. So let's say you are given a set of information wherein the measurement of angle A is 20 degrees, correct? And then it says little a is 5, little b is 15. And then the question is, how many triangles are possible? Okay, so this is the trick, all right? So I told you at the beginning, always set it up this way. Is your angle 20 degrees? All right. Now this is your side B, 15. Okay. This is your side A, which is opposite angle A. It is 5. Now the question is it enough to make a triangle? Now, what you need to understand is this. If there was a triangle, at least one, you would probably think that, okay, it would have been a right triangle. That's the simplest one to think about, right? Okay. It has to be a right triangle going this way, which means that if that is so, all right, this height here, okay, this height of the triangle, which I will call H, all right, H, should be the same as 5. Yep, all right, meaning that H should be equal to 5. If not, then we have a problem. If H is longer than 5, then that means that 5 is not enough to make a triangle. You get what I mean? Okay, so our problem is we don't even know how long H is. But then if you go back to Math 10, we have worked with right triangles, and SOHCAHTOA tells you that if you choose SOH for self, sine opposite hypotenuse, that means that this this height, which is opposite 20 degrees, all right, we can actually create a sine ratio, all right? From Math 10, it's sine of 20 degrees equals opposite over hypotenuse. The opposite side to 20 degrees is h, right? And the hypotenuse in the right triangle that we have is 15. Okay. If we want to isolate h, we will be multiplying both sides by 15. All right. So these two cancels out. Therefore, our h is 15 sine of 20 degrees. And if you use your calculator, you will see that, oh, h is 5.13 or something close to that. Now that we have found h and we are comparing it to side A, we see that h is longer than side A. What does that tell us? Side A, which is 5, is not enough to create a triangle. All right? In this case, there is no triangle that exists. No triangle exists. Therefore, there is no solution. If the question in this case was not to find out if there is a triangle or not, but it goes like, okay, solve the triangle, solve for the missing angles and the other missing side. Okay, you have to be careful with that because you have to establish first that there is a triangle. In this case, there is no triangle, therefore there is no side and there are no other angles to look for. Okay, so if you're thinking, okay, so what do we have? Well, all you have is that sort of incomplete picture wherein you have this 20 degrees, oops, what am I doing? Okay, 20 degrees, and then this one is 15, and then this one is A5. That's all you have. Okay, what is it? Well, it's an incomplete picture. Okay, now, what about if there was, okay, so let's look at another set of um, information. Okay, so let's say you have an angle A equals 37 degrees. And then you have side A equals 3. And then you have side B equals 5. All right. So we need to figure out again how many triangles are there. And once we have established it, we can tell what the other sides are and what the other angle is because we just have to do the sine law. Okay. All right. So again, let's look at how we set the picture up. This is your angle A, 37 degrees. This is your side B. Okay. 5. Okay. So if you're thinking, all right, so where is um, angle B anyway? So it's probably somewhere here. All right. Okay. And then this would be C. Okay. Okay. So where is side A? This one here, like dangling or something. Okay. Now, again, what we are trying to figure out is that 3 enough as we swing it around? Okay. So as we move that 3 that way, or that side that way, is it enough to reach the bottom to create a triangle? So once again, we need to think about the height. All right, h. What is that height h? So since we have a right triangle here, therefore the sine of 37 degrees is equal to h over 5. Okay, or the h equals 5 times sine 37 degrees. And right now, I suggest you begin, trying it out yourself so that you can also practice. And you will see that h would be equal to 3.009, blah, 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 or let's just say that it's just 3, all right? Now, what does it mean? Since we found h to be 3 and a to be 3 also, that tells us that, okay, so if we are to swing that 3 or that side A, it can actually take the place of h, meaning we could have actually created the picture wherein this is your 37 degrees, all right? This is your 5, And this would be the 3. It would have completed it. All right. So what does it mean? In this case, yep, there is one triangle possible. Okay. Now, if you're thinking, okay, in summary, how do you determine if there is one triangle possible? Well, you would compare the length of side A, all right, side A, which is this one, to the height. It is always about the height, all right? So it's always about comparing side A and the height. If the height is equal to side A, therefore there is one triangle possible. Okay. Now, what about this one? If you have an angle 30 degrees, all right. This is a different question, okay? All right, so angle A is 30 degrees, and then side A is 20, and then side B is 16. Okay. Now, in this case, if I'm going to be putting in the value 16 here, and then maybe 20 is going to go that way, right away, you can tell yourself that, okay, I think there is one triangle possible, because all you have to do is extend this part here, all right? If you extend this one, you will reach it here, okay? Now, this one gives you one triangle also. And what is it that is sort of the hint here? How can you tell that there is one triangle? Well, if you are given one angle and then two other sides, just like what we have been doing from the very beginning, and side A is greater than side B, then right away you know that there will be one triangle possible. All right. Okay. So far we have seen those instances where there would be no triangle or there would be one triangle. And now I'm going to show you the instance wherein there's going to be two triangles. Now, if you remember what I showed you in the previous, right at the beginning, wherein there were two triangles, okay? This is what I will do for you. I'm going to be using the same set of values. Angle A is 30 degrees. A is 10. B is 16. Okay, so again, here we go. 30 degrees. Okay, side A is this one, 10. Side B is this one, 16. So, how can you tell if there is no triangle, there is one triangle, there are two triangles? So once again, it's about the H, right? So let's create the H or the height. Now that H would be given or can be computed by sine 30 degrees equals H over 16. Or H is equal to 16 sine 30 degrees, or H is equal to 16 times 0.5, sine of 30 degrees is 0.5, and that is 8. Now, what does that tell you? Okay. Since H is 8, it is smaller than A. All right, it is smaller than 10. Now, if it is smaller than 10 and A is smaller than B, all right? So meaning side A, which is 10, is greater than H, all right? But at the same time, less than B, okay? There are two triangles possible, okay? Which is what you saw in the earlier picture right at the beginning, okay? So now, if there is no triangle that exists, then really there's nothing to do. If there is one triangle that exists, once you have seen that there is one triangle, using the ratio of the sine law, you will be able to figure out quickly what the other angles and the other side, the other missing sides would be. Well, this one, you have to do each triangle. So meaning to say, all right, so we already know there are two triangles, right? So let's just say this is one triangle, 16, 10, okay, 30 degrees. All right. So this is one possible triangle, while the other one would be shown in a little bit. Okay. So how do you do that? Well, let's say you are trying to find angle B. All right. So 16 over sine B equals 10 over sine 30. All right. Okay. So I think I showed you the way that I do this, the Mexican hat way, or some of you would be doing another way of solving this, which is cross multiplication. I don't know what you learned from your previous teacher. All of those would probably be correct. So I'll just do it the easy way as far as I'm concerned. We're trying to find out what angle B is. So I will multiply this, all right, and then divide by this. For those of you who were with me in Math 9, you would have seen this before. Therefore, sine B equals 16 sine 30 over 10, all right? And that would have given you um, 0.8, okay? Therefore, angle B is equal to the sine inverse of 0.8, or about 50, uh, what is it, 53 degrees, all right, 53 degrees, okay. So now we know that this is 53 degrees. So what about angle C? Well, angle C would just be 180 minus 30 minus 53, so that would be 97. All right. So we found one triangle, and then I leave um, the other side for you to do. This is side C. You should be able to solve for that using the sine law. Okay. Now, what about the other triangle? Now, look at it this way. So this is the triangle that we have been able to do. All right. Now, what if we swing this side? All right. We swing it this way. So now it is, oops, now it is now over here. All right. So what I'm saying is this side here, all right, it was swung and it is now over here. Okay. Now there's something I'd like to point out to you. Since this side was just the same side as this one, all right, it was just moved and swung. That means they are of the same length, right? Therefore, this one is the same length as this one, okay? Now, if those two sides are the same, therefore, this angle here would be the same as this angle here, all right? So you have an isosceles triangle, isn't it? Okay. The isosceles triangle that I'm talking about is this one, all right? Not the big one. Okay. Now, we know that there is another triangle that would look like this, right? Oops. We saw that earlier, right? This is your 30 degrees, this is your A, okay? This is your C, this is your B. The question is, what is this angle going to be? This one right here. Or in this case, this one. Yeah. Okay. So I'll do it again, okay? We are looking for this angle here, which is the same as this one here. All right. Now, do you notice that since this angle and this are the same, all right, therefore, this angle here, I can actually make into a 53. How do I know? We already saw that earlier, isn't it? From the other triangle. Okay, that's 53 degrees. Therefore, this one here would just be 180 minus 53, right? So that means this one here is 180 minus 53. So that would be what? 127 degrees, right? 180 minus 53. So this one here is 127 degrees. Therefore, this angle here, angle C, would be 180 minus 30 minus 127. So this one here, angle C, would be 23 degrees. Okay? So, you were able to see how the other angles look like, what the, or how you find the two different angles, the two different triangles, and really the key is to ask yourself, all right, is the A going to be more than the height? Okay, so I know at this point it may not be that easy to understand. Like I said, it is not something that you would probably be getting in one sitting. You may probably need to watch this video again and again, or maybe you would just think that, oh, the way I presented it is not clear. On Schoology, I have about 4 different versions for this one coming being shown by different teachers. So hopefully you can also look at that just so that it will be clearer to you. All right. So I would like to come up with sort of a summary of what I just talked about. Okay. With all of those examples that I gave, the idea was there was one angle that was given, and then there are two sides, right? If you notice, the angle that was given was always acute, all right? Therefore, if theta is an acute angle, all right, the different possibilities is that if the side opposite, okay, opposite the angle given, which is called A, right, is less than the height, what did we see? No triangle, no solution, all right? What did we see when A is equal to the height? There is one solution, all right? In fact, it is a right triangle, okay? In what other instance did we see one solution? Oh, when side A is greater than B, there is also one solution. When are there two solutions? When A is greater than H, but A is less than B. There are two solutions, okay? When I talk about solutions, I talk about the number of triangles, all right? Now you might be thinking, okay, but that is when theta is acute. What about when theta is obtuse? So for example, all right, so when theta is obtuse, so what it means is that when the angle given is more than 90, so something like this, all right? So this one is the obtuse angle, all right? And then you have B here, this is angle A, this is side A, okay? All right. So the only time when there is a solution is when A is greater than B. Oops, let's move that away. There is going to be one solution. All right. Now, if you're thinking, what about if A is equal to B? Well, if A is equal to B, then that means that A will just go inside with B. You won't have a triangle. What about if A is less than B? That means A will never be able to reach up to the bottom, meaning it will never be able to get here. All right, so you are unable to create a triangle. Okay, so I hope I was able to give you a good idea of how to solve this. Once again, I am asking you to look at the other videos that I have for you on Schoology. We are going to spend quite a bit of time on this lesson, so most likely I will spend at least one more class day for this before we move on. And if we need one more class day, that's fine. All right. Meaning if we have to spend 2 or 3 class days just for this lesson, so be it. So I think that's about it for me. I will be posting the homework, and until next time, bye for now.